Okay. Now we are going to see soil soil mechanics. There are two practicals we are going to see. One is Atterberg limit test and Proctor compaction test. Okay. Then in this test, first of all, under Atterberg limit test, we will see Atterberg limit test, and under Atterberg limit test, liquid limit and plastic limit test are the most important test we are going to see. So under that, I am going to explain you first. We will see about that liquid limit test, because the soil the soil, you can see here in next slide, you can see when you are adding water, it will reach, the soil will reach plastic limits first. The second, it will reach the liquid limit. Okay, you want to know when you are adding water little more. So first it will reach the plastic limit. You know, from the solid state, it will become here. First of all, it will reach the plastic limit. Then after that, it will reach the liquid limit. After that, it will go through the liquidity state. So the difference between plasticity index, you know, the equation is liquid limit minus plastic limit. So first of all, you want to find liquid limit and the plastic limit. According to that, you can see about the behavior of the particular soil using the plasticity indexes. Okay, you know what is index. Okay, the next, Atterberg limit test. Here you can see what is Atterberg limit test. Atterberg limit test are the limits of a water content. Okay, you know there's a water content. What is water content? We already show from our previous practical also. We already saw what is water content. Then used to define soil behavior. Okay, it used to define the soil behavior. Okay, behavior of the soil, particular soil. You can get the sample from anywhere else, and from that sample you can say the behavior of particular soil. And the consistency of soil according to that Atterberg limit test give the following diagram. Okay, consistency you can find from here. So when you are adding water, increasing water content becoming a weaker. Okay, when you are adding water to the soil, it will become weaker. Please switch off your mic, please. Then here, you know, from solid state to semi-solid state to plastic state, it will reach the plastic state. After that, it will reach the liquid state. Okay, you can get some idea from this figure. Then after that, what is liquid limit test? Normally it is here, it is described here. Okay, normally it is described here. The above part, I'm not going to tell more, but you want to see the soil is said to be its liquid limit. Okay, its liquid limit. One particular soil, it is said to be its liquid limit when exactly 25 drops are required. Okay, drops are required mean when you are doing the liquid limit test, there is an apparatus that is called Casagrande apparatus. I can show you from the video. I will show you in next few slides. I can show you through the video and also the figure. You can see there is a rotating handle is there. Through that handle, you will rotate. So when you are rotating, before rotating that one, you will place the sample. There's a cup. Okay, there's a cup. Okay, brass cup is there. You want to fill that brass cup. Okay, you want to fill that brass cup. Straight. I will show you some photos. Yeah, here. This is the liquid limit Casagrande apparatus. Okay. This is the liquid limit test Casagrande apparatus. This one we are calling Casagrande apparatus. Soil sample is this one. You are adding some water and make a paste sample. And after that, using this spatula, you can paste that sample like this. Okay, you can paste this sample like this figure. to do the liquid limit test. So that moment, after, by using, there is a grooving tool is there. Okay, there is a particular tool. By using that tool, you can make this kind of grooves. Okay, you can make this kind of grooves. After making that groove, this one is the handle. You can rotate this one. Okay, here for a 1 second time, 2 revolutions you want to apply, and that time it in this place it will get closer. It will get closer. So it should be close. It will get closer, but we can't say in which revolution. Okay, in which revolutions mean in how many blows you are going to give. Okay, how many blows you are going to give to close this one. Okay, to close this groove to 13 millimeter, I mean half inch distance. Okay, likewise it will close. That time you want to take the sample. Okay, but it can't be, you can't take the blow 25 times blow, and also okay, number of blows in our apparatus it will show here. I can show you that apparatus also. It will show the blows. Okay, so the blow should be 25 when it reach 13 millimeter, but we can't get that one exactly. We can't get that one. Okay, we can't get that one. No, so at that situations we are applying blows, and we are finding only this kind of 13 millimeter closure of the sample in what moisture content of this particular sample, and also how many blows. We can't say exactly it will be 25. It may be below 25 and it may be above 25. Okay, you can get that one. So you want to take that one for minimum 6 samples to plot a graph. You want to plot a graph, and after plotting the graph, you want to plot graph in log scale of number of blows and water content in the y-axis normal scale. Okay, water content. That situations, after drawing the graph, you can find the value of water content for particular mean 25 blows, which we are saying as a liquid limit. We are saying 25 blows is the liquid limit. So that I am saying you want to find from the graph where 25 blows, what is in that situation, what is the water content. Okay. Then the part is plastic limit. Okay. Okay. Now we will come to that sentence. Okay. Yeah. Liquid limit test here. A soil placed in the grooving tool. Now you can read and understand here. A soil is placed in the grooving tool, which consists of a brass cup. I already show you brass cup is there. A hard rubber base. Under that one, there's a hard rubber base. Yeah. A groove is cut at the center of the soil bed using a standard grooving tool. Yeah. The cup is then repeatedly dropped from a height of 10 millimeter. What is that one? Okay, there is a gap you want to maintain. 10 millimeter gap you want to maintain here. Here, this is the hard rubber base. Between this cup and this hard rubber base, you want to maintain 10 millimeter gap. Okay, I will show how to maintain that one. Okay, here by adjusting these screws, you can maintain that one. Okay. Okay. Then we will see. Okay. 10 millimeter until groove closure to 12.7 millimeter. The soil is then removed, and after that you want to remove the soil from that one particular soil sample at that situation, and you want to find the moisture content of that one. Okay, by keeping that sample to that one, we can find that one. A soil sample is rolled into threads until it becomes thinner. Here, this is under plastic limit. We are going to see now plastic limit. The second one is plastic limit. Okay. Now, if you have any doubts regarding the liquid limits, you can ask after I play the video regarding liquid limit. Okay, I will play some videos regarding liquid limit. After that, you can ask some questions. Okay. Then we will see a second one under Atterberg limit test, plastic limit test. So now here we are preparing a sample by applying water to the sample, and a soil sample is rolled into threads. So we will roll it into some kind of elliptical shapes or some kind of roller shapes, and after that we will roll in that sample on the glass plate, and that thread should be, you want to roll that one until it becomes thinner and eventually break at 3 millimeter. Okay, it should be break at 3 millimeter. 3 millimeter mean you are rolling like a thread. Okay, like a thread mean like a rod shape. Okay, the diameter of that rod should be 3 millimeter. We have standard rod. That diameter of that particular rod is 3 millimeter. You can compare the size. When you are rolling, you can compare near that one. You can keep and you can compare the size of that particular crumbles. Okay, you want to, when you are applying the rolling, when you are applying by using your fingers, okay, that time the particular sample should be breaks at 3 millimeter size. That sample we are getting. Okay, we are going to get that sample and we are going to find the moisture content of particular sample. So after finding the moisture contents, we are taking around 3 samples. We will take around 3 samples and we want to find the average of that particular sample. Okay, that particular sample average we will find, and that is called normally plastic limit test. Okay, that is very quick test. We can perform in the lab. We can perform these two tests in the lab. Normally, that sand cone test is we already done. That test in the field we did in the field. That is a field practical. Then sieve analysis test you can perform in the lab. Likewise, Atterberg limit and also the Proctor compaction also you can do in the lab. Okay. In some situations, you may do the practical or do the test in the site also, the Proctor compactions when needed. Okay. Then plasticity index, by getting the value of plasticity index, I already told you, between the liquid limit and plastic limit, you can find some values. That value is called plasticity index, the difference between liquid limit and plastic limit. Okay, according to that, you can say about that particular sample plasticity, the behaviors you can say. Okay, I will show you some of the behaviors. Then is a ratio, the liquidity index, that is the ratio which signifies the relative consistency of a cohesive soil. What is mean by cohesive soil? What is cohesive soil? What are the soils? The cohesive soils, normally cohesion, that is stickiness of a particular soil. Okay, stickiness. Okay. Then you can understand the clay is stickier than sand, normal sand. Okay. There is a friction is there in the sand, but not in the clay. The clay is a cohesive soil, but normally we can say the sand is not a cohesionless, it is a cohesionless soil. Okay. I mean, C, there is a coefficient of cohesion is there. C, normally we are saying. Okay. We will learn in future that C is equal to Z when the C parameter is equal to 0. That is called sand. Particular sand, we are saying C is equal to 0, and for the clay, it is not equal to 0. Okay, there's a value. The natural state, when the liquidity index is 0, it means the soil is at its plastic limit. Okay, liquidity index is 0, that is in the plastic limit, and when it is equal to 1, when you are finding when it is equal to 1, the soil is at its liquid limit. And I already show you these things. Moisture can, you already show that. We already saw that one. This soil specimens, this is the soil specimens. Okay, let's see, move to the next slides. Now let's see the plastic limit test. This is the plastic limit test things, the apparatus, the tools you needed. Okay, moisture cans and spatula and glass plates you must need it. Okay, then plastic limit test, ellipsoidal soil mass you want to prepare first, and after that you want to roll like this, and after that you want to roll it to this kind of crumbles. Okay, the thickness of a particular crumble should be 3 millimeter when compared to that rod, 3 millimeter standard rod. Okay, then this is the liquid limit test equipment apparatus. You can count the here in our apparatus also. It will count the blows, number of blows when you are applying the rotations. It should be 2 revolutions per second. Okay, here the thickness of this standard tool, okay, grooving tool, it is 10 millimeter. So we will keep under between this rubber base and brass cup, and we will tight these screws. By adjusting these screws, you can set up this apparatus, and after that you will place the sample and you want to start the practical. Then this is how it will be, and 1/2 inch size. When you are doing the practical, then it will reach the 1/2 inch. Just and liquid limit state, you can see before the test. Okay, you want to place the sample. Okay, you want to place the sample like this. I mean the depth of the sample around. Okay, around the depth of the sample, it should be around this amount. Okay, this is before the test. It should be before the test. The sample, it is a cross section of that cup. This is the sample, and there's a groove. Okay, there's a groove, and around 21 millimeter. This is yeah, this is around 24 by 9 millimeter or 10 millimeter. This is around 9 millimeter or 10 millimeter. The depth of this one. Okay, it is the depth of this one is around 9 to 10 millimeter. You want to place the sample. When you are at the liquid limit, after its closure, the shape will be, cross section will be like this. Then below the liquid limit, it will be appear like this. Above the liquid limit, it will be appear like this. Okay, cross sections. So if you get this kind of thing when you are doing the practical, you can understand the scenario. Whether it is above the liquidity when you applied water is more or lower. Okay, then when you are plotting the thing, I already told you the x-axis you are using logarithm scale. Okay, log scale you want to use. Water content and moisture content also. We are saying moisture content also. That is water content. That is percentage you want to mark. Then you can plot the graph. Then I already told you in the stage of 25 blows, you want to find the liquid limit. That's the value of a liquid limit. 46.9 is the value here. Okay. Then here, plastic limit state, that the thread above the plastic limit, it will seems like this. At the plastic limit, it should be seems like this. Okay, around 3 millimeter. Okay, then this one, thread below the plastic limit, it will crumble like this, but should be eventually crumble like this. Okay. Then here, the observation for Atterberg limit is normally I got this one from the previous past students' observations. Okay, normally we are using This kind of observation sheet, because we are combining two practical, that's it one time. So in your observation sheet, type of test, liquid limit, liquid limit, liquid limit. The samples normally 4 they taken, but we will take 6. Okay, we will take 6. And here plastic limit and plastic limit, normally we will take 3 likewise. Okay, the number of blows we got, we can write here. Then that time container number, there's a container number without complexing. At the end of the situation, when you are getting out, you want to put the number in that container. So okay, then it will be get easy for you all to get the values at the end. Okay, the particular correct values you can get. Then weight of the soil. Okay, weight of the wet soil plus container. Okay, weight of the wet soil plus container. You want to measure at the initial stage. After getting from the oven, dry soil plus container, you can measure. Then weight of the container you need it. So through that you can measure the moisture content of particular sample, and you know the blows. So you can draw the graph. From that graph you can find the blows, the water content needed for 25 blows. So that is the liquid limit. Then plastic limit, 3 samples. I already told you, when it is crumbled, okay, at the 3 millimeter diameter shape rod. So you can get the plastic limit. You can average, you can take the average of that one. So that is the plastic limit of the particular sample. Okay. Then normally this is our lab manual. Okay, you can read this one. I will provide you. If you want, I can provide you this presentation also. Okay, you can learn after completion of the session also. Okay, before coming to the practical, please read and please understand the thing and come. I will ask Viva. Okay, I will ask pre-lab questions from you. Then if you want to must answerable. You all want to must answerable. Then liquid limit test, you can read here. Okay, I already told you. Here you can understand the apparatus things. What are the things you needed? All the things here. Okay. Okay, I already explained about those things. Okay, and here the procedure. When the procedure you want to consider, you want to take 250 grams of oven-dried soil sample. Okay, we have oven-dried soil sample. You want to take 250 grams. You want to take. Okay, which is passes through the 425 micrometer. Okay, 0.425 micrometer sieve you want to use, and which the sand passes through, the soil passes through that particular sieve. You want to take 250 grams. Okay. Yeah. You can read this one when you are on. Here, when you are maintaining the thing, okay, when you are maintaining the blows, okay, it's better to start from 15. Okay, 15 mean when you are applying the water, okay, at the 35 blows, you can, that should be closer. Okay, you want to maintain that one around 35. Okay, around 35, and between 35 and 15, around 35. when you add more water, then it will close quickly, no? When you're adding water, it will close quickly. So if it is closed, if you want to close quickly, you know that mechanism. So if it is more quickly connected, then little bit you want to add, it should be between 35 to 15. Okay. If you add more, it will close quickly. So around 15, you can see at the blows of 15, the water content is more. At the blows of 35, the water content is, it should be lower, no? You want to understand that one. So when you are adding water, little bit, so you want to maintain that one. The result, when you are plotting the things, you want to maintain that one. You want to consider that one. Okay. Okay. Observation sheet format is there. Okay. So you can combine that one. You can add this one. I'm going to collect one report. Okay. Only one report you want to give me for the Atterberg limit test. Okay. You can read this one here. I already explained that one. So no point if you again I'm explaining. This is about plastic limit test. Okay. So here the apparatus requires all the things are there. Okay. Okay, here where liquid limit is the liquid. In this slide, you can see where liquid limit is the liquid limit. I mean, LL is the liquid limit. Okay, between the range of 0 to 35, low compressibility. We are saying that is low compressibility. And 35 to 50, medium compressibility. The compressibility of the behavior is medium. The liquid limit is bigger than 50, high compressibility. Okay. Then plasticity index, I already told you. There's a plasticity index value. The plasticity index of A and A. A mean there's a graph here. You can understand this graph is there, standard graph. Okay, from that graph, there's a A line. I will provide this one. Yeah. Here there is a line. You can see the line is going through here. This line is called A line. Okay, plasticity chart, we are calling this one as a plasticity chart. It is to liquid limit and plasticity index. So through this chart, you can understand there is a line. So here you can see here the plasticity index is above plasticity index of A line. The soil is clay. Above the line is clay, below the line is silt. You can see. Okay. Above the line is clay and below the line is silt. Okay. Here, clay. In plasticity chart, the following symbols are used. This one is a clay, and these are the things. MH means silt, high compressibility. Through that chart, you can understand the things. Okay. Okay, let's see about that Proctor compaction test. And after completion of this demonstration, we will watch some videos. Okay, through that videos, we can learn more. Okay. Then Proctor compaction test, laboratory compaction test. We are doing laboratory compaction test, and this is our lab 2. I mean balance. This one is our 4th lab, but balance is 2, so this one is 2nd one. Okay, so I already done 2 for you all. Okay. Then origin, normally it's where its origin is fundamental compaction of fine grained soils. Relative new, R.R. Proctor, who is the person invented is the R.R. Proctor, so his name comes as Proctor test. Then purpose of this laboratory compaction test to determine the proper amount of mixing water to use when compacting the soil in the field. Okay, in the field you must need to compact. The situation will become. Okay, compaction should be done in most of the situations in the construction industry. So that's in that time you want to know the proper amount of mixing water. Okay, if you add more water, some kind of happening things, the soil behavior will be changed, no? According to that. You add lower water also, there is behavior differences there. You can understand that one. Okay, it is not good. More water is also not good. Lower water, adding lower water content also, it's not a good one. You can understand from this practical. To use when compacting the soil in the field and the resulting degree of denseness, okay, which can be expected from compaction at the optimum water. When you are adding optimum water, maximum dry density you can get. Maximum dry density you can get at the optimum water. Okay, at the optimum water content, you can find the maximum dry density from this practical. We are plotting for the, in x-axis, we will plot for that water content. To the y-axis, we will plot dry density of the particular sample. And we will draw a graph and we will find the optimum moisture, maximum dry density at that particular point. Okay, in that particular point, we will find the optimum moisture content. We can find here. Okay. The Proctor test is the impact compactions. The hammer is dropped several times. Okay. Here we have a tool in the apparatus. A hammer is, that is called hammer, is dropped several times on a soil sample. Several mean around 25 blouses we will allow. On a soil sample in a mold, there is a mold is there. Okay, the mass of the hammer, height of the drop, number of drops, number of layers of the soil, and the number of and the volume of the mold are specified. Okay, it is standard. Those are the things should be standard. Okay. Okay, this is the standard Proctor test equipment. Okay, the sizes are given. I already told you those are standard. So diameter, 4-inch diameter is there. Okay, you can, this is a collar, extension collar. You can remove that one. Okay, you may have already seen this one in our lab. So this is the hammer. You can use this hammer by through this point. You can extend that one and you can apply the load through this weight. Okay. The dropping height is this one. It is standardized. The weight of the hammer mass also standardized. Okay. This is the photography of particular apparatus. This is the schematic diagram. Then this is the photography of the particular apparatus. So there's a collar, you added that one. Okay. When you want to extend this hammer up to this height, drop height, and you want to apply the load there. Okay. Then you can find the maximum dry density when you are applying the water, optimum water content. You can find. Here, the procedure, when you're applying that loading arrangement, okay, you want to start like this. Okay? The first 4 blows should be like this: 1, 2, 3, 4. After that, 5, 6, 7. This is the arrangement. Successive blows arrangement is this one. Okay. In this way, you want to, when you are applying, you want to consider this one. Okay. The plot dry density, you want to plot that graph to the dry density versus water content, moisture content. Okay. Each compacted sample, it should be, you want to do the particular. So, and this is our apparatus. Okay. This is the manual remmer. Okay. Manual remmer. Graduated slinter to apply water, moisture cans, straight edge, or called spatula also, and soil specimen you can take here, and trowel, mixing pan, and mold is there. Okay. First of all, you want to apply the water and mix thoroughly, and after applying water and mix thoroughly, okay, you want to fill this mold. You want to fill this mold in 3 equal layers. So first equal layer, so 3 equal layers. So first equal layer you want to put this, for first equal layer you want to put the sample and you want to apply the loading. Like previous arrangement, you want to apply the load by using the remmer. So after completion of that 25 blows, again second layer you want to fill. Okay, you want to fill second layer, and also you want to apply second stage of loading. You want to apply as 25 blows, and third layer also, after filling this collar, you want to apply the load of third, and after completing that one, you can remove this collar. Okay, you can remove this collar. So the second stage, you can fill up to this one. Third layer, you can fill up to this one. When you are applying the load of third one, you want to fix this collar and you want to apply. After applying the load, you can remove this collar and you want to cut this sample like this. Then you can weight this one. Before that one, you want to weight the empty mold. Before starting the work, you want to weight the empty mold. Okay. So after applying the loading arrangement also, I have 1 minute time.